Hi guys, welcome back. Today we'll be doing question 7, financial maths. The question reads, a business buys a machine that costs 120,000. The value of the machine depreciates at 9% per annum according to the diminishing balance method. Determine the scrap value of the machine at the end of 5 years. Okay, so we know that the formula is going to be A is equal to P 1 minus I to the power of n. Why is it minus? Because it's depreciation, so the value will decrease over time. Okay, substituting our values in, the P represents the principal amount, which means the amount which was originally bought at, which is 120,000. 1 minus the interest rate is 9%, converted to a decimal is 0.09, and n represents the number of years, which is 5. The value of the equipment after 5 years will then be 74,883,86. Moving on, 7.1.2. After 5 years, the machine needs to be replaced. During this time, inflation remained constant at 7% per annum. Determine the cost of the new machine at the end of 5 years. Okay, so this is basically the same thing as the depreciation. We're using the exact same formula, except now it's inflation. So we need a positive there because the value will increase over time. Plus I to the power of n. Okay, again, our principal amount is 120,000. That's the amount we started off with. 1 plus I. The inflation rate is now 7%. So converted to a decimal is 0.07 to the power of 5. Because that's the number of years we are inflating for. At the end of 5 years, the equipment will be 168,306.21 cents. 7.1.3. The business estimates that it will need 90,000 by the end of 5 years. The sinking fund for 90,000 into which equal monthly payments must be paid is set up. Interest on this fund is 8.5% per annum, compounded monthly. The first payment will start immediately and the last payment will be made at the end of the 5-year period. Okay, so it's important to know your usual scenarios where everything stays the same in the formula, and from that usual scenario you can now adapt it and make the necessary changes to the equation. Okay, so normally in a sinking fund, what we have is a payment that starts in the month, not an immediate payment. Okay, so this is something different to the usual sinking fund setup. Okay, so nonetheless, we're going to write out our future value formula, which states it's 7.1.3. Future value is equal to x into 1 plus I the power of n minus 1 all over I. Okay, from here we can just substitute our values in. We are looking for the value of the monthly payments. Okay, so in the formula we are looking for the value of x. We know that the value of f is 90,000. That's the value of the sinking fund. Okay, x stays x. 1 plus I. Our interest rate is 8.5% per annum. It's compounded monthly. So converting the 8.5% to a decimal, we get 0.085. And because it's compounded monthly, we have to divide it by 12. To the power of n, n would be the number of compounds in this period. Okay, so since it's compounded monthly and it's for a 5-year period, it's 12 compounds per year. So we have 12 times 5, which gives us 60. But they've told us that they've made an immediate payment. An immediate payment means there's an extra payment towards this sinking fund, which would not normally be there if it were the usual 1 month later scenario. So we'll have to add 1 to it and we get 61. So to the power of 61 minus 1 all over the interest rate, which is 0.085 divided by 12 because it's monthly, and we get our value of x to come to 1184.68. Moving on to 7.2. The question states that Lorraine receives an amount of 900,000 upon her retirement. She invests this amount immediately at an interest rate of 10.5% per annum compounded monthly. She needs an amount of 18,000 per month to maintain her current lifestyle. She plans to withdraw the first amount at the end of the first month. How many months will she be able to live from her investment? Okay, so the first thing we need to do is first to identify whether it's a present value or a future value. Okay, easy way to decide is present value, you're getting money right now, either in installments, you're taking out money monthly, or future value is you saving up to buy something. So the money is in the future. Okay, in this case here, we know that she's withdrawing an amount every month, therefore it will be a present value. Okay, so just going to write down our present value formula. 7.2 P is equal to X into 1 minus 1 plus I to the power negative N all over I. Okay, from here we can go and substitute our values in. We know that the P amount is 900,000 because that's the amount she receives. So 900,000. The X amount is the monthly withdrawals, which is 18,000 into 1 minus 1 plus I. We know that the interest rate is 10.5%, so it's 0.105 divided by 12. Why? Because it's a compounded monthly, and to the power of negative N. N represents the number of compounds, and that's what we are looking for. Divided by 0.105 divided by 12. Okay, solving for this will result in a logarithm. So you'll have a log equation, and using logs you'll be able to solve for n. I'm just gonna write the final answer of n to be n is equal to 66.04 months. Okay, so the question did not specify in what, they did say in months, so we'll leave our answer as that.